get more geometry and more properties. And a lot of this, again, is just you learning and making sure you know things. Some of the wording you don't need to worry too much about, but a polygon is essentially just a 2D shape. You should know the area of a triangle, a rectangle, a parallelogram, a trapezium. But if you don't know a trapezium, you can always split it up into a rectangle and a triangle. I had a teacher who taught it to me, and you could probably find it somewhere on YouTube actually being sung. But it was to the I can't sing. I probably shouldn't do this. But anyway, it was to the tune of Pop Goes the Weasel.
Half the sum of the parallel sides times the height between them. That is how to calculate the area of a trapezium. Half the sum of the parallel sides times the height between them. That is how to calculate the area of a trapezium.
So there's a trapezium. There's also a few bits about circles. Now, if you've ever had to watch the YouTube video on the circle song.
Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d.
So we've got some stuff about circles. Don't worry too much about tangents and sectors. That's again right at the top end with the higher stuff, but see how you go. Make sure you do exactly the same as we've done with the previous bit. Go through them, tick them off, and we're going to start working through these questions. Okay? We're hoping for those of you, if you're watching this for the June exams, hopefully you're going to get an extended formula sheet which will have some of these formulas on it, so you don't need to know them, but we don't know yet exactly what's going to be on that, so it's worth bearing that in mind. Okay, so let's have a look. We've got a circle, and this circle has a radius of 4.2, and we want the length of the circumference. Now, the formula that we should know is that the circumference equals pi d, and d is diameter, which is double the radius. Okay, so let's just make sure we summarize our circle. We have our circle, we've got the center to the edge is my r, or my radius, and double that is my diameter. And circumference means all the way around the edge. So if we know the radius is 4.2, it means that the diameter is double that. 4.2 times 2, so 8.4. And in your calculator, you're just going to do pi, which might be, depending on which calculator you've gone, you might have to press shift and the times 10x button, or you need to find your pi button, which is like a very special number. It's one of the fundamental numbers. And they want it one decimal place. Your calculator gives you 26.389. One decimal place means we only want one number after the decimal place. We look at the number after it. It's bigger than 5, so we round it up and it's 26.4. Right, so our next question is we've got the front the front elevation, the side and the plan. So that's looking at something front on, looking at it from the side and looking at it from the top are all the same. Well, then it's got to be a cube. So this is going to be a cube because it's all the same no matter how we look at it. And if it's a circle, no matter where you're looking at it, you've got a sphere. Okay. So now we've got a circle and it has a center O and it's telling you to draw a sector. So a sector is a slice of pizza. So it's a nice slice cut from the center. So if you're going to draw a sector, you're just drawing a slice of pizza. If it asked for a segment, you would have drawn it chopped across somewhere, you know, like annoyingly, so somebody's not done it properly. But for a sector, it's literally just a slice of pizza, okay? Right. We've got a cuboid and we want to work out the volume. Right, area you times two numbers together. A length is always 1, area is 2. Volume, you should be timesing 3 numbers together. We're given 3 numbers, we're literally just going to multiply them. So 7 times 5 times 10. This was in a non-calculator paper. 7 times 5 is 35. Times 10, we add a 0. 350 centimeters cubed. So if we think about volumes, it's the whole solid mass. So it's 3 things times together. Areas, 2 things. A perimeter all the way around the edge is lots of lengths added together. Oh, which is the next question. It says work out the perimeter. So you've got one side. So first of all, if you're asked for a perimeter, fill in all the sides that you're not given. So if it's a rectangle, that must be 5 and that must be 7. So up and down equal, side and by side equal. So you've got 7 plus 7 plus 5 plus 5, which gives you 24. Right, we've got a triangle, has a base 9 and a perpendicular height. If it had given you all the sides, you're not interested. You're interested in the one that meets it at right angles. It doesn't matter if it's not exactly on the thing. So the area for triangles are half times 9 times 5.6. So 9 times, so when you plug that all into your calculator, you get 25.2. Okay, we've got a rectangular carpet and it measures 6 by 8. So that's the whole thing. And you've got a little square on the top. Okay, show 1/12 of the carpet is covered by the rug. So let's find the area of the carpet. So area of carpet. Now area, remember 2 things times together. So we're doing 8 times 6. And that's going to give you your area of your carpet. So you've got 48 meters squared. And then we've got the rug, which is a square. So it means both sides are the same. If that's 2, that's also 2. And that's 4 meters squared. Now, as a fraction, you're going to put 4 over 48. And you're going to say to yourself, does it cancel down? It does. It cancels to a 12th, which is what we expect. So it's correct. And also it's a show that. So it's saying show that this is true. So the fact that you've got it to be true means it must work. Okay, so we've got a cuboid. The 2 largest faces. Now what's a face? It means a side. So the 2 largest faces are blue, the others are green. All right, so let's work out what each one would be. So we've got the 2 sides on either end, which would be 5 times 3. So these are going to be 15 centimeters squared. This one is going to be 9 times 3. And that's going to be on the front and the back. And that's going to be 27 centimeters squared. And then we've got the top and the bottom, which is 9 across and 5 up. So 9 times 5 gives you 45 centimeters squared. So the largest ones must be the top and the bottom, which are 45. So the largest ones are 45 plus 45, so 90. So these ones are blue, 90 centimeters squared is blue. And then the others, which will be 27 plus 27 plus 15 plus 15, is 84 centimeters squared, which is green. And it says, is the total blue greater than the total green? And your answer is yes. And because you've drawn all those numbers on your diagram, that would be enough working, but you can write more, obviously. A circle is drawn on a centimetre grid. Draw a tangent. A tangent is a line that just meets the circle. So you will draw it with a ruler, obviously, and you could have drawn it anywhere. So that's a tangent. If I pick another colour, that's also a tangent. You know, if I take this red one, I could have, oh God, no, that one, that's gone through. Sorry, it should have just touching the circle. So that's probably not a good one. Let's try that red one again. So I could draw it anywhere, just touching the circle. And obviously yours will be a straight line with a ruler. Okay, so now we've got each shape has an area of 24. Okay, so we're thinking about the different areas. and you've got to figure out the missing length. So for a rectangle, the area is the base times the height. So we know that the height times 6 equals 24. So something times 6 equals 24. That something has got to be 4. And for the triangle, it's half the base times the height equals 24. Half of 16 is 8. So all you're going to do is 24 divided by 8 to give you 3. So those are nice questions. Okay, here is a quarter circle of radius 6. Right, this was in a non-calculator paper. Think about what the area of a circle is. I told you if you don't remember it, go listen to that really annoying song and you'll know the area of a circle is pi r squared. So we're going to do pi times 6 squared. 6 squared is 36, so we can write 36 pi. But that would be a whole circle. We only want a quarter. So for a quarter, we're going to divide that 36 by 4. And because it's told us to leave it in terms of pi, we just write 9 pi. Okay, we've got a diagram which has a rectangle and a right angle triangle. Okay, we want the area of the rectangle. So first we need to find, so we know BC to CD is 1 to 2. First, so we know if that for every one of this is 2 along. Okay, so we're like, all right, let's find all our missing sides to help us out. So if this is 8, and we want to find the other one, we have to times that by 2 times 8, so that's 16 centimeters. We still don't have enough information to work out the area, because we need this height as well. But hopefully you recognize from the last session when we looked at Pythagoras, this is the hypotenuse. So a squared plus b squared equals c squared. We know the c squared is 17, and we want to find one of the other sides. So if we do 17 squared minus 8 squared, we get 225. Take the square root of that, and you get 15. So you know this is 15. So the area of the rectangle is along the bottom. We've got 16 plus 8, so we know this is 24 centimeters, sorry. And we're going to do 24 times 15 to give us 360. All right, so hopefully that makes sense. Okay, we're going to look at the last question, and this was the last question of a foundation paper, okay? But even if you're doing higher, this is likely to be in your exam. So we've got two solids. We've got a cylinder and a hemisphere. And it gives us the volume for the hemisphere. So we don't need to worry about if it's a weird one, they will always give you the formula. Okay, which solid has the greater volume? So for a cylinder, essentially what a cylinder is a circle copied all the way down. So we work out the area of the circle, which is pi r squared, and then times it by h. So we're going to do pi times 4 squared times 10. And when we do 4 squared, we get 16 times 10, so 160 pi. Okay, so that's the volume of the cylinder. The hemisphere, it gives us a formula. 2/3 times pi times r cubed. So 6 cubed. Okay, so 6 times 6 times 6, which would be 216 times 2/3 is 144 pi. And it said which one has the greater volume, so you'd write the hemisphere has the greater volume. And as long as you've written all that working, it's easier to see. Now, if I can't remember if it was a calculator or not, if it was a calculator paper, not a problem, you could put it in decimals, but you should be able to either way see really easily. One is definitely bigger than the other. Leaving it in pi actually makes this a little bit easier. So hope that helps. Leave a comment. Let me know what you get, how you're getting on. Let me know what exam papers or questions you'd like to go through. So I'm recording this on the 9th of October. So we're going to have a lot more calculator tips. I managed to sort through them. My baby contract, which is me helping my sister with my niece and nephews, is kind of over because she can drive and do bits herself. I'm still going to be doing a lot of it, but I will have a lot more time. So I want to use it to make content before I go back to school in the new academic year. So I've got this academic year to really make headway with this channel, and I want it to be useful. So please put your comments in. I know it may look like I've not seen them yet, but I will be working through them, especially over Christmas and the New Year. Okay, well, take care and have a good evening.